So in this lesson, we are going to graph linear inequalities. And we have graphed inequalities on a number line. Now we're going to graph them. So just as you have used inequalities to describe graphs on a number line, you can use inequalities to describe regions of a coordinate plane. So we're going to now graph inequalities in a coordinate plane. So when we had something like this, x is less than 1, we remember that greater than or less than was an open circle. Okay? Greater than or equal to, less than or equal to is a closed circle. So here, and we just were using that in the last lesson with piecewise functions. So this is a closed circle and open circle. So x is less than 1, it would be an open circle on 1. Where is x less than 1? Where is it less? So look at your two fingers. Is it less on when it goes negative? So it's going to go here. And that's going to be really helpful if we look to see where is it going to be, whether less than or greater than, depending on what we have. Now on a number line, okay, we would do that same kind of thing. X is less than 1. Well, we know if that we ever have just x and a number, if we just have one variable, it crosses through that variable. So it's going to be a vertical line going through at 1. Now, here's where it's different. In linear inequality, we're going to have a boundary line. And instead of greater than or less than being an open circle, it's now going to be a dashed line. And if it's greater than or equal to, less than or equal to, it's going to be a solid line. Okay, so this one is going to be a dashed line. So we're going to dash a line right here. Okay, and then just like we did over here, where is it greater, where is it less? So we want x is less. Is x less on my left finger or on my right finger? It's less over here. So we would shade over here. Okay, and a linear inequality describes a region of the coordinate plane that has a boundary line. Okay, so now it's going to actually be a line that divides it. The solutions of an inequality are the coordinates of the points that make the inequality true. Okay, to make it true, it's going to, if true, the point is in the shaded area. Okay, each point on a dashed line, dashed boundary line, is not a solution. Just like when we had an open circle, it's not part of the solution, so 1 is not part of the solution. So it's an open circle. Well, now it's going to be a dashed line. And each point on a solid line, boundary line, is a solution. So this right here is a solution. This is a solution. This is a solution. Anything in the shaded part is a solution. Anything in the shaded part. Now the only difference here, it's not a solution if it's on this line. Okay? How do you know where to shade above and below? So I'm going to give you the mathematical thing, and then I'm going to show you what I use, of course. For an inequality written in the form y is less than or y is greater than, okay, this is going to, whoops, sorry, misspoke. For an inequality written in the form y is less than or y is less than or equal to, so if it's less than, you're going to shade below the line. That gets a little fuzzy. So again, I'm going to show you another way you can look at that. For an inequality written in the form y is greater than or y is greater than or equal to, it's going to be above. It's going to shade above the line. Okay? Now we're going to go through the steps on what we need to do here. There's going to be one little change in the wording, but that's fine. Okay, so we're going to graph the line y is less than 2x plus 3. The first thing we're going to do, we change that point. That should actually say, as far as I'm concerned, that should say plot. We don't want to graph a line, because graph lines means we've drawn in the line. We want to plot the points. Okay, we want to plot the points of the line. We're going to plot the points of the line, and then we'll decide if it's going to be dash or solid. Now, in this one we have less than. So if this one is less than, the points on the boundary line do not make the inequality true, so they are not part of the solution. So this is going to be a dashed line. Okay, so we can plot the points using our slope and y-intercept. So our y-intercept is 3. Okay, that's our y-intercept, so we're going to go to 3. Now I'm going to go up 2. My slope is 2 over 1, so I'm going to go up 2 over 1. I'm going to go down 2 over 1. And we're just going to plot them. Okay, so that's our first step. Now we realize that it's a dashed line because it's less than. So we're going to use our handy-dandy straight edge. Why is it I never can find it? There it is. So we're going to draw on our dashed line. And we're just going to dash it. That's all we're going to do. See how that's a dashed line. Now we're going to shade. Now, this is less than, so we're going to shade. According to this, if it is less than, we're going to shade below, which is true. Here's what I like to do. See these 2 fingers? These are awesome. These are very helpful. So what I like to do is that it's determining where y is less than. Where y is less than. So put your finger on the y-axis. Yep, do it with me. Put your fingers on the y-axis. Now, which finger is less? Where is y smaller? Because I want less than. See, I want less than. So where is it smaller? It's smaller down here, right? This is the finger where it's smaller. So I am going to shade down there. I shade so that, and this is where it gets so fuzzy. This is below the line, way up here. It is below the line, but it's harder to see. So that's the reason I look at my y-axis. Okay, so we're going to shade below. And we use this. If it's less, we're going to shade below. But for me, I just need a little more help, so I use my fingers. Now we want to check to see what point is in that region. And if it is in the shaded region, it's a solution. If it's not, then it's not a solution. So 2, 5. So here we go. 2, 5. 1, 2, 3, 4, 5. Oh, that one was close. But there's the point, 2, 5. Is that in the shaded region? Yes, it is. So yes, a solution. And they want us to explain. The explanation is going to be in shaded region. Because in shaded area or region. Okay, it doesn't matter what you call it. Okay, what about 0, 3? 0, 3. Oh, look at how tricky this one is. 0, 3, see that? It looks like it is, but notice it's on a dashed line. So this one is not a solution, and the reason is it is on the dashed line. They're trying to trick us, but we're smarter than that. Okay, now -5, -1. No brainer. See how that one's way over here? This is the point, -5, -1. Is that in the shaded area? Nope. So not a solution. Not in shaded region. Okay, see how that works? Okay, nothing too tough. Let's do another one. But if you ever get confused, what am I supposed to do? This kind of steps you through it. Plot the points. Decide if it's dashed or solid. Okay, graph the line. Then decide where I shade above or below the line. Okay. Here we go. We're going to graph this one. You're going to try it. Okay. You're going to pause your video right now. And you're going to graph this line. So you're going to go through. You're going to plot the points. Sorry. You're going to plot the points of this line. You're going to then go and decide if it's dashed or solid. Then you're going to decide if you shade it. Go. So hopefully you've had a chance to do that. You recognize that your y-intercept is 0, -1, and your slope is 3 over 1. So this is what I would do. I plot the points. I've plotted the points. Now I'm going to determine if it's dashed or solid. This is greater than or equal to. So therefore it is going to be a solid line. This is a solid line. Okay, here's my hint. My stupid way of remembering it is, see how this right here, there's an extra line? So it's going to fill in all the little dashes. So this is going to be a dashed line. Sorry, this is going to be a solid line. And I pretend like that this equal to fills it in. But what I'm supposed to be doing mathematically is that's part of the solution. Now I have to determine where to shade. Okay? Y is greater than. Where is Y bigger? Is Y bigger here or Y bigger here? It's bigger with my left hand. So I am going to shade up. And that pen's dying too. But I'm going to shade up. Okay? Good. And that's all you do. There's not a lot of work to show on it, but look at all the work you've shown me. You've told me it's a solid line, so it's part of the solution. You've told me where you shade. You've graphed the line. There's a lot of work there, so it's really important you do it well. Okay. Now, all the equations we've had, inequalities we've had so far, have been nice and in slope-intercept form. in order to tell whether you shade above or below, you may need to write the inequality in slope-intercept form. Heck, not only whether you shade, but you also need to know what to graph it. It's lots easier. So you need this in slope-intercept form. Okay, so we want this in slope-intercept form. And hopefully you know slope-intercept form, and you have that memorized. That's y equals mx plus b. That's slope-intercept form. Okay? So the first thing we have to do is we have to rewrite this to be in slope-intercept form. So I have to get y by itself as my whole goal. That means I'm going to move the 3x. I'm going to subtract 3x from both sides. And I get negative 5y is less than or equal to negative 3x plus 10. Okay, now, oh, this is important. Oh, okay, you might want to take your earbuds off just a little bit. Look what we have here. We're going to have to divide by a negative. Did you say divide by a negative? Hope I didn't hurt your ears. We're going to divide by a negative. Remember, when you divide by a negative, your inequality sign switches to go the opposite direction only when you divide by a negative. Okay, so my inequality sign actually switched because I'm divided by a negative. That would have been a positive 5, no switching. But see how I went from going left to going right. So less than sign to a greater than sign. So really important if I divide by a negative. If I don't divide by a negative, don't worry about it. Okay, so now we're going to plot the boundary line. So negative 2, we're going to go up 3, 1, 2, 3 over 1, 2, 3, 4, 5. We're going to go down 1, 2, 3 over 1, 2, 3, 4, 5. And we're going to determine, is this going to be dashed or solid? This is solid. And remember, if you're ever watching the video, if you want to pause the, wait, what did I just say it is? Solid. If you want to pause the video and do it on your own and then just check to see what your answer is going to be. Okay? And then you can always come back in. So we now have plotted it. We've determined we're going to use a solid line because it is greater than. Now we're going to shade. Those of you who just totally get it, great. I'm going to use my fingers. I want y to be greater. Where is y bigger? Right up here. So I'm going to shade up this direction. Okay, shade above the line. Okay, now we're going to check to see if these are solutions. So 5, 1. Oh, look, they're trying to be tricky again. Look at this one. They said 5, 1. That is on the line. So if it is a dashed line, not a solution, but it's on a solid line, that's a solution, yes. On the solid line, it's part of the solution. Okay, what about 0, 0? No brainer, 0, 0. It's definitely in that shaded area. Here's your shaded area up here. It's definitely there. So yes, it's a solution in the shaded area. Okay, 7, negative 7. You can probably guess it's not going to be because that's the way they usually do it. 7, negative 7. 7, negative 7. Way down here. Nope. Not in shaded area. Okay, so you're going to do this next one. You're going to pause your video and you're going to do this next one and try it. Okay, it's going to follow this. So just kind of follow these steps. Go. So on this one, you had to get it in slope-intercept form first. So you subtracted 6x, and then you divide it by 8. Notice, when you divide by a positive, your inequality signs do not switch. Only when you divide by a negative. So this one, it's just going to keep going straight forward. It just acts like it's an equal sign. So our y-intercept comes out to be 2, and our slope is negative 3/4. So we plot the points 2. We're going to go down 1, 2, 3 over 1, 2, 3, 4. We're going to go up 1, 2, 3 over 1, 2, 3, 4. Okay, and the other thing, notice I went from negative 6x to negative 3/4. You can leave it as negative 6x. I just have to count more. So I'm going to reduce it down to lower terms. Okay, I plotted my points. I'm now going to determine if this is dashed or solid. Is this dashed or solid? It is dashed. Nice job, dashed. So dash that line. There we go, dashed line. Now we're going to determine where we shade. Y is greater than. So where is y bigger? Y is bigger up here with my thumb. So I'm going to shade above the line. I'm going to shade above the line because it's where y is greater. For those of you who just go, y is greater, I'm going to go, yep, above. Great. For me, if I put my fingers on, it helps me. So I'm going to shade above the line. And solutions in this. What about the solution 3, 0? Well, that's right on that dashed line, not a solution. Anything over here, these are all solutions. Okay, good. Let's look at your homework. So you're going to graph linear inequalities. And this is the assignment for today and for tomorrow for inequalities. So this is not due on Tuesday. This would be due Wednesday, or I'll check it off on Thursday. So just to let you know, this is not due on Tuesday. So you're going to graph these. Same thing as what we've been doing. This one is very similar to the very first one I showed you. Just be mindful of there's only one variable there. I'll just give you that hint. Think about that. Okay, on the back it says write the inequality of each graph. So we're going to write the inequalities for these. Okay. So what we need is we're going to need the y-intercept and we're going to need the slope for all of them. And just a side thought, if I would ask you, if I would go, okay, is the point, let's say 2, 5, is that a solution in this grid? If I were given that point, what, go over 2, 1, 2, 3, 4, 5? No, that's not the shaded area. So this is not. Okay, just to let you know. Okay, so what's my y-intercept? That's just a side note. Y-intercept is 0. What is my slope? Well, here's a whole number point, and here's a whole number point. So I am going up 1, 2, 3 over 1, 2. So my slope, I went up 3, 2 to the left, so that's a negative 3 over 2x. And then I have a y. Now, is it shaded above or below? It's below, so it's going to be less than. It's dashed, so that's my inequality. Y is less than negative 3/2 x plus 0. See how I did that one? Okay, now the tricky one is this one right here. The reason this one is tricky is because it does not have a y-intercept we can use. So we actually have to use 2 points and go with point-slope form. So on this one, not a big deal. We're going to go 2, 5. There's one of my whole number points, and my other whole number point is way down here. Okay? So I would actually have to plug it into y minus y sub 1 is equal to slope times x minus x sub 1. We didn't do a lot of these. That's the reason I'm showing you this one myself. And just because it doesn't hurt. So we're going to determine the slope. So I go up 1, 2, 3, 4, 5, 6, 7, 8, 9. I went up 9, and I went over 1, 2, 3. Hey, that means that there was one in between there. So let's go down 1, 2, 3. Oh, there was another whole number point right there. I missed that one. Okay, so then I can take one of my points and plug it in. Y minus a y value, 5, is equal to, this is reduces down to 3. X minus the x value, that x value is 2. So there's an equation. Sorry, oh, we can't do an equation, we have to do an inequality. This is a dashed line. This is where it's shaded. It's hard to tell. So that's below. So y is below. Y is less than. So then I would just rewrite this. Or not. Okay? So that's how I'd find an inequality. Now in these is what I was talking about. Which graph includes the solution 0, 2? So look at those. Which graph includes that solution? Same thing here. This is a shaded part. Okay? Just see where those points are and see if it's a solution. Okay. So that is it for day 1. Remember that our test is coming up, so if you haven't already, start on the review for this unit. Start on the review if you haven't already done so. Thank you so much. If you have questions, you know where to find us.